Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about collections class. In this video I will share a few of the most commonly used collections method that you can use in your daily life to make your life easy. So make sure to watch this video till the end. So let's get started. Alright guys, so let's begin this video with the very first question, that is, what is collections class? So in order to answer this question, let's move to the source code of collections class. So here is the source code of collections class. On top of it, you will see that the package directive, and you will see that this class belongs to java.util package. So all the classes that belongs to java.util package are utility classes. This means the collections class is also a utility class, and this class is a member of Java collection framework. Now the question over here is, what is the purpose of collections class? So the collections class contains methods that is used to manipulate collections, and here I have listed all the most commonly used methods, and these are max, mean, frequency, disjoint, binary search, sort, copy, fill, reverse, rotate and shuffle. And I have divided all the most commonly used method into two groups. One is collection and one is list. So all these methods like max, mean, frequency, disjoint works on collections, meaning the collection that implements collection interface. And the remaining methods like binary search, sort, copy, all of these methods operate on collection that implements list interface. Let me show you with diagram. So here is the diagram of collection hierarchy. So the collections that implements collection framework are ArrayList, linked list, ArrayDeck, treeset, hashset, link hashset, priority queue. Almost all the collection class implements collection interface. Now talking about the collection that implements list interface are only two, that are ArrayList and linked list. So all of these methods works on ArrayList and linked list, whereas these methods works on any type of collection that implement collection interface. Okay, now let me tell you guys the cool thing about this collections class. If you check out this class, you will find that all the methods in this class are static method. So this means we do not have to create the object of collections class in order to use these methods. And second thing is, all the methods of this class works on collection. So you can pass any type of collections in any method to solve a specific problem. And guys, one more thing to note here is, collection framework only works with the non-primitive data type, and in Java we represent all non-primitive data type with objects. So let's create one class in order to create objects so that we can see all of the methods one by one. So let's create a class with the name box, okay, and give it a property private int size. Okay, now let's generate getter and setter and constructor. Okay, so guys, as we are using collections class, many of the methods in collections class uses comparable interface to compare the objects like binary search and sort. So let's implement comparable interface on this class. So write implements comparable, okay, and this is a generic interface, so let's pass it box. Okay, now let's try to override the method compare to. Override method compare to. Now this dot size minus o dot size. Now here you can see that the compare to method is expecting a return type integer. So here there are three possibilities of returning the value as integer. One is the negative number, okay, one is the 0, and one is the positive number. Okay, now in case two objects are exactly equal, in that case we return 0. If the first object is greater than the other object, then we return positive number, and if the first object is smaller than the other object, then we return negative value. So that is why we have written here this dot size minus o dot size. Okay, this belongs to the current object and o belongs to the object that are going to be compared. Okay, now let's try to override more method, like first of all toString method, okay, and few more methods we have to override, that are equals and hashcode method. Okay, click next, next. Okay, so what is the reason of overriding equals method? Because few of the methods of collections class uses equals method to check the equality of two objects. Okay, just like binary search uses compare method to compare two objects, there are few methods that uses equals method to check the equality of two objects. That is why we are overriding equals method and compare to method of comparable interface. Now we are good to go. Now we can check all the methods one by one. So guys, let's move on and see the first method of collections class, that is maximum method. Okay, so to check the maximum method, first we have to create a collection. So let's create a collection array list L equal to new array list. Okay, and let's add few objects to this list. L dot add, give it 5, give it new object, new of box, and the size of box is 5. Similarly, let's add few more boxes, 5, 4, 2 and 1. Okay, now we can call the maximum method of collections class max. So what this method does, this method simply gives the maximum object among all the object in the list. So what this method does, this method returns the maximum object of all the object contained in the given list. Okay, so it's going to return a type box. Okay, the return type is going to be casted to box. Now let's give collection to this maximum method as argument. Okay, and now print the value of box p.size, get size. Okay, run the program. Now you will see that the maximum size of box among all the boxes in the given list is 5. Okay, so this is how maximum method works. Now let's move on and see the next method, that is minimum method. So just replace the maximum with minimum and let's run the program. It will give minimum as 1. So the minimum size of box that are contained in this given list is 1. Now let's move on and see the next method, that is frequency method. So let's call collections dot frequency and give it a collection AL. Okay, and this method also takes one more argument, and this method takes one more argument whose frequency needs to be calculated. So let's give a box of size 1. So what this function does, it simply counts the frequency of the given object, and here the object is box of size 1. Let's run the program and you will see that the frequency of box of size 1 is 1. Now let's add one more element to this list, that is 1, and 1 here is also 1. Let's run the program and see, you can see that the number of box of size 1 are 2 because there are 2 boxes of size 1. So this was all about frequency. Now let's move on and see the next method, that is disjoint method. In order to check the disjoint method, we have to create 2 collections first. Okay, so let's create 2 collections, AL1, AL2, AL2, AL2 and AL2. Okay, now let's call system.out.println collections dot disjoint. Okay, and this method takes 2 collections as argument. So give it AL and AL2. Okay, and what this function does, this function is going to find the common elements between these 2 collections. If there is no common element between these 2 collections, this method is going to return true. If this method finds any common element between these 2 collections, then it's going to return false. So let's run the program. This time all the elements are same, so it's going to return false, right? Because this time all the objects of both the collections are same. Now let's make it different. So let's remove these 2 and make it 6 and 7. Run the program. This time there is no common objects between these 2 collections. That is why it is returning true. So far so clear. So this is how disjoint method works. So we are done with all the methods that works on collections. Now we are going to see all the methods that works on list type of collection. This means the collections that implements list interface. Okay, so guys, let's move on and see the next method, that is binary search. Okay, collections dot binary search. Binary search method takes 2 arguments. First is the collection and the other one is the key that needs to be searched. So give it a key new box of size 1. But binary search only works if all the objects in the given collections are in sorted order. So let's first sort all the objects. So let's move to after 1, then 4 and then 5. In case the objects are not arranged in sorted order, the binary search method may give unexpected output. Okay, so now all the objects are sorted 1, 2, 4 and 5. So we are calling binary search by providing the collection and the key needs to be searched. Now let's store the return value into this variable. Okay, and print the value of R on the screen. Okay, run the program and you will see the value is 0. This means the box of size 1 is present at index 0, and that is correct. Okay, now what happens if we provide a key that is greater than all the objects of the collection? So here the box size is 10 and here the size of boxes are 1, 2, 3, 4, 5. In this case, let's see what it's going to return. Here we get -5. So guys, if we provide a key that is greater than all the elements of the collection, then it's going to return a value that is based on this expression, that insertion point -1. Okay, so here all the elements are smaller than the given key. That is why the insertion point is going to be the size of the collection, and size of collection is 1, 2, 3, 4. So that is equal to the insertion point. So -4 minus 1 is equal to -5. Okay, and here the insertion point defines the point at which this particular key would be present. Okay, now what happens if we provide a key, let's say 3. Now let's try to search a box with size 3. This time it is giving -3, and this time also it is following the same expression, minus insertion point -1. So it's going to return a key of the element that is greater than 3, and this time it is 4, and index of 4 is 0, 1, 2. So -2 minus 1, that is equal to -3. That is why it is returning -3. So 3 is the position at which this key would be inserted. Okay, so far so clear. And guys, one more thing to remember, that binary search internally uses the binary search algorithm to find the specified keys in the list of objects. Okay, so I hope this is clear to you. So guys, let's move on and see the next method, that is sort method. So let's call collections.sort, and this method takes collection as argument and it simply sorts all the objects of collection in natural ordering. This means in increasing order. So let's first quickly unsort all the objects of the collection. So let's make it 4, 2, okay, so on and so forth. And now let's print this collection on the screen. AL, run the program, and you will see that all the objects of these collections are printed in natural ordering or increasing order. So you can see that box of size 1 appears first, then box of size 2, then box of size 4, and then box of size 5. So this is how sort method works. Now let's move on and see the next method, that is copy method. So let's call collections.copy. Now copy method is used to copy all the objects of one collection to another collection. So to use the copy method, first we have to create one more collection so that we can copy all the objects of this collection to this collection. Okay, let's make it AL2. Here also L2, here also L2, here also L2, here also L2, and then make it size equal to 0 so that we can copy the objects of this collection to this collection to see the real effect. Now this copy method takes destination. So destination is L2 and the source is AL. So this means we are going to copy all the objects of this collection to this collection. So first of all, let's print all the elements of AL2 collection. Okay, and then copy from AL to L2, and again going to print AL2 collection. Okay, let's run the program and see. Prior to copy operation, the objects of collection L2 is box of size 0, all the boxes of size 0, and after copy you will see that all the objects from collection 1 gets copied to new collection, that is L2, and you will see that box of size 4, box of size 2, box of size 5, and so on and so forth. So this is all about the copy method. Now let's move on and see the next method, that is fill method. Okay, now let's write collections.fill. Now fill method takes list collection as argument and the object that is filled to all the elements of this collection. This means if I provide an object like new box of size 10, then this box is going to assign to all the elements of these collections. Okay, now let's print the collection on the screen, L, and there we go. We will see that the new object is assigned to all the elements of the given collection. So here you can see box of size 10, box of size 10, box of size 10. Okay, so this is how fill method works. Now let's move on and see the next method, that is reverse method. Okay, reverse. This method takes list collection as argument. So let's give it L, and what this method does, it's simply going to reverse the order of all the elements in the given collection. So let's print the collection on the screen, AL, run the program, and boom, you will see that prior to making a call to this method, the elements are box of 4, box of 3, box of 5 and box of 1. And after calling this method, we have box of size 1, box of size 5, box of size 2 and box of size 4. All of these boxes are arranged in reverse order. So this is how reverse method works of collections class. Now let's move on and see the next method, that is collections.rotate. And this method takes list collection as argument and it's going to rotate the elements of the collection by some distance. So that is why it takes one more argument, that is the distance. Okay. Now let's print the collection on the screen. Run the program. You will see all the objects of this collection printed on the screen. Now let's change the value of distance to 2. And now run the program. Now you will see that the object of given collection is rotated clockwise by 2 distance. So the first object is going to be box of size 5 and then box of size 1 and then box of size 4 and then box of size 2. So this is how rotation works. So basically what rotation method does, it rotates the elements of the collection by some distance in clockwise direction. Now let's move on and see the last method of this episode, that is shuffle method. So let's call collections.shuffle. Okay, and this method takes collections of type list. So give it a list, and what this method does, it simply shuffles all the objects of the given collection. We can also say that it's going to randomly permutes all the elements of the given collection. So let's print the collection on the screen and see the result. So run the program and you can see that all the objects of these collections are shuffled randomly. So first is going to be the box of size 2, then box of size 4, then box of size 1 and then box of size 5. So this is how this shuffle method works. It simply randomly shuffles all the objects of the given collection. So guys, by now I hope that you have a good understanding of all the methods we have discussed so far, like maximum, minimum, frequency, disjoint, binary search, sort, copy, fill, reverse, rotate and shuffle. So I hope by now onwards you will use all of these methods in your day-to-day life to make your life easy. So on this note, let's end this video. So guys, if you have learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy, subscribe to the channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.